Hello, today we are going to discuss our second guessing strategy, the estimation strategy. This one is one of my favorites because I feel like people that maybe are weak in geometry, this can really help people that have forgotten geometry for one reason or another. The first problem that we've got here is number 4, so if you'll find that one in your handout. We're going to work this problem together. I'll do it the correct way just so that you see the math, and then also I'll do it the estimating way. So like if we forget our math, then what are we going to do? Just skip the problem? No, we're not going to skip the problem. We're going to be able to figure it out based on estimating. So it says a ladder is 10 feet long and reaches 8 feet up a wall, as shown below. How many feet is the bottom of the ladder from the base of the wall? This is just your typical Pythagorean theorem question. So, of course, the legs are A and B, and the hypotenuse is C. So we're going to do A squared plus B squared equals C squared. 8 squared plus, we don't know, squared is equal to 10 squared. So 64 plus x squared gives me 100. Subtract 64 from both sides, I get 36. So the square root of that is 6. My answer then is definitely H. Now, let's say you forgot your Pythagorean theorem for whatever reason, and this works on anything that you may have forgotten. The ACT claims that the pictures are not drawn to scale, but in actuality, they may very well be drawn to scale. So if you look at this, I can use my scorecard. I just have a copy of an ACT scorecard here. And I can use it to measure how long this line is. So from here to here, I'm just going to set my ACT scorecard right next to it, and I'm going to mark that off. This is what we're trying to figure out from here to here. Well, I know what 8 looks like. 8 goes from this. 8 is this distance. Alright, so we're clearly less than 8 here. As a matter of fact, I can even figure out probably what a 5 looks like by measuring this line, because 10 goes from the top to the bottom, and that's going to put my 5 right in the middle. So this is probably where 5 would be. If 10 is the entire distance, then 5 is going to be in the middle. So I know this answer right here is somewhere between 5 and 8. Clearly we know the answer is 6, but if I didn't, then I could eliminate 2 of my choices just by measuring it and not doing any math at all. I didn't do any math at all. Square root of 2, you're going to find, is like 1.4 something. So if I put that in my calculator, which you may need to do, that is clearly not the answer, because again, I know the answer is between 5 and 8. I might want to stick in square root of 164. Let's clear that out. Square root of 164 is 12.8. Clearly not the answer. So just measuring using my scorecard helps me, because the pictures are drawn to scale. They are drawn to scale. Alright, let's try another one. This is number 41. If you can find number 41 in your handout and follow along, it says the end-on view of a cylindrical milk tank on its support is shown in the figure below. The interior radius of the tank's circular end is 4 feet. The interior length of the tank is 25. So the interior length of the tank, it does say, is 25 total feet. So we know it then says the center of the circular end of the tank is 2 feet above the top level of the support. So I go ahead and I put the 2 in here. What is the width in feet of the support? So that's this distance right here. What is this distance is the question. Well, this distance obviously is the same as this distance. I'm going to go ahead and work this with math, just so you can show how it's worked the correct way, and then we'll use our guessing strategies. I am going to draw this extra line right in here because the radius of this thing is 4, so I know that this has to be 4 also. This will let me find this distance, which I then can double to find the entire distance. So using Pythagorean theorem, legs squared plus legs squared, we don't know how long this is, we'll just let it be b, equals hypotenuse squared. So b squared equals, this is 16, I'm going to subtract that 4 and get 12. So b is equal to the square root of 12. Now if you remember how to simplify your radicals, that's 4 times 3. So the square root of 4 is 2. I'm going to move it to the outside of the square root sign and leave the 3 on the inside. So now that's just this line right here. I'm going to have to double it for the entire line. So the answer is B, 4 square root of 3. Now, let's say I don't remember any of that math. So I got to figure out how long this is. So I'm looking at this, and I know that this length right here is 2. I know 4 is the longest side. This is not too hard because I know this is going to have to be probably bigger than 2 but smaller than 4. But I can double check it. This distance right here is 2. I know for sure. So I use that to measure here, and clearly that line segment is longer than 2. I know that this is 4. I can mark that off. So I go and measure. This distance is clearly longer than 4. Now, it would be nice if I knew what this entire distance was. So from here to here is 4. And then if I move this over, looks like I got another 2. So now I've used up 6, and it's going to be a little bit more than 6. Okay, and I'm using my ruler. I'm making a ruler with the corner of my scorecard. I know that my answer has to be just a hair bit greater than 6. So I start with the middle one. We learned that in our last video, that you always start with the middle one. I'm going to check 4 times the square root of 5 to see what that equals. This is about 8.9. That's too much. Too much there. So I'm going to go down 1. If 8.9 is too much, then I've already eliminated 2 answers. So I'm going to go down here, 4 second square root of 3, and whoa, 6.9, that's about what I want. I want this to be greater than 6. So I've for sure eliminated 2 of these answers. If I just wanted to double check myself, I'd pick the last one. 2 square root of 3 is about 3.4. So that is clearly not enough. I would choose B. And I didn't need to know any math at all. I just used my scorecard to measure the lines. I love that method. So again, if you don't know how to do the math, then try that. Try measuring with your scorecard. Here's another one. This one, however, is angles. In the figure below, B is on AC. B is on AC. E is on DF. AC is parallel to DF, and BE is congruent to BF. What is the measure of angle DEB? Right here. Now, before I go on here, I just want to make sure, and I want you to use this advice at your own risk. Seriously. But I read that I took time to read this entire paragraph. But if you look here, everything's written on the picture. Everything I need to know is written on the picture. The ACT does that a lot, where they will give you all the information in a paragraph, and you'll sit there and read the entire thing, but they clearly have everything marked here. The only thing they didn't have marked was that this line right here, AC, is parallel to DF, which I'm a little surprised that they didn't. They probably should have put some little marks like this just to show that these 2 lines are parallel. They probably decided not to do that just because it looks a little awkward. Usually those are you know, one right on top of the other, so maybe that's why they didn't. But what I'm saying here is that you can oftentimes just read the question and answer this problem. You don't even have to read all of that up there. You just read the question of these geometry problems, and you can look at the picture to get the given information. Alright, now if I were going to solve this one, I would know that this has to be 35 degrees because they're parallel, and alternate interior angles are parallel. I would know that this is 35 degrees also because it's an isosceles triangle and base angles are congruent. So that means this one right here is going to be 180 minus 35, which you can see is 145 degrees. So H has to be the answer. Now, how can I use my scorecard to figure that out? This angle is clearly obtuse. That takes out this one completely. All right. We know where 90 is because I know what a 90-degree angle is. I'll take my scorecard and I'll compare this. This right here is a 90-degree angle. I've got a 90-degree angle, a handy one right here on my scorecard. So I can compare all these to my 90-degree angle. All right, I know that this is 35, okay, and even if I don't, I can set this here, and maybe you can see through your card, but I know what a 45 looks like, so if that's 45, then this has to be 180 minus 45. So I'm looking about 135 degrees. I could eliminate these two choices and then just be down to these two and have a 50-50 shot at getting it right just by knowing what a right angle looks like. I can make a right angle, I can make a 45-degree angle just with my scorecard. So anyway, that'll help you. It wouldn't exactly help you get the exact answer, but it would help you eliminate 3 of the choices. Alright, you can go ahead and try the rest of these yourself. I'll give you the answers. If you want, go ahead and pause the video and try number 30, and then turn the video back on and I will give you the answer. Alright, hopefully you tried number 30, and the correct answer here is H. Hopefully you got that by using some of our strategies that we talked about. What is the sum of the angles? That would be this angle and this angle. What is the sum of those two angles together? Look, I didn't read any of this. I just read the question. I can see everything that's marked right here. I know what a 50-degree angle looks like, so if I were to estimate this, then I would compare that angle. Maybe I would set this scorecard down, and with my pencil very lightly I would mark what a 50-degree angle looks like, and then I would go compare that to this angle. Wow, that looks pretty close, maybe a little bit more than 50 degrees. I might call that an angle, maybe that's 55 degrees. And then I'd go back here and I'd measure this one. And I'd measure this angle at about 50. I can see it through. I know you probably can't, but I can see it through there. So maybe I'd call that a 30-degree angle. So if I add those together, I'm estimating at about 85. So this clearly can't be the answer. This clearly can't be the answer. This is not near enough. So now I've eliminated 2 of the choices. Alright, and I'm down to either 80 degrees or 90 degrees just by estimating. And we already know the answer is H. Alright, I think that's enough examples on estimation. If you want, you can try these last 2. Pause the video now, and then I will give you the answer to number 35. Alright, hopefully you tried number 35 and got A, letter A. Pause the video now and try number 38. Try number 38. The answer to 38 is H, letter H. Alright, hopefully that helps you on estimation.